Hello, Math 111 students. This is Michele, and I'm currently doing a podcast to help you with the projects. I'm getting a lot of feedback that students need some additional assistance with the projects. So what I wanted to do is put together a podcast for you, which will kind of help you navigate through the project a little bit. I'm not going to, of course, give you the answers, but what I will do is I will kind of help you along, kind of give you an idea of how to work through this project. So the first thing we're going to do is we're going to look at the instructions, and we're going to look at the directions on what needs to be accomplished, and it is a two-part project. So you'll see that there's a number 65 and a number 66 because we actually did pull it out of the book. And I thought it was a really good tool to kind of help you with geometry because it's actually something that's real life. I think all of us have at one point picked up a paintbrush and painted something in our lives, such as maybe our apartment that we live in, or if we have children, their rooms. If you have a baby, you get a nursery together, or if we've ever redone our kitchen. So it's a very common thing, painting, so that's why I wanted to use this as a project to help you learn geometrical figures and word problems. Okay, so here we have we're going to call it a family room. So let's say you live in a house and you have a family room in your house. What it's asking us to do is to read the two-part question, word problem, and what we're going to do is focus on one thing at a time. So instead of trying to work it out all together, we're really just going to focus on part A and then focus on part B first. So in painting a room, the word problem asked, the walls of Anita's family room are illustrated below. All of the walls are 8 feet high, and the rear and the front walls are each 22 feet long. Each of the side walls is 16 feet long. The French door is 3 feet wide and 7 feet wide, while the sliding door is 6 feet wide and 7 feet high. So I'm reading these dimensions because they're going to really help us later on. The window on the first side wall is 4 feet by 3 feet. The window on the second wall is 2 feet by 4 feet. You'll see why I'm going through and giving you dimensions of not only the walls, but the slider door and the doors. Okay, so Anita's landlord is going to be painting her family room. She has agreed to let Anita purchase the paint so that she can choose the brand and the color she wants. The landlord will reimburse Anita only for the cost of the paint used. Anita must buy only as much paint as she needs since the extra paint cannot be returned. Describe the quantity of paint that Anita should purchase if the landlord will put one coat of paint on all of the walls and the ceiling of the family room. Okay, so in most cases when you do paint, you probably put on 2 or 3 coats. But in this particular case, it's asking us to only work out this problem with 1 coat. And if you look at the very last sentence in this description, that is what we're going to be focusing on. So what we want to focus on is that 1 coat of paint is what we're going to be working with. But not only are we going, or actually the landlord is going to be painting on the walls, but also the ceiling. So you want to take into consideration when you're doing your dimensions in your project, you want to make sure that you cannot forget the ceiling, because it certainly would look funny if you painted all 4 walls and then the ceiling was not painted as well. So okay, so in this slide here we have the dimensions. So I copied and pasted the dimensions up top, so as we're working along we can kind of look at the dimensions and not forget, based on our memory, we have the illustration for us right here. So if the landlord has to paint 1 coat of paint on all of the walls and the ceiling of the family room, let's look at the dimension of each wall. Okay, So we're just going to break up the 4 walls. We're not going to focus on the ceiling for right now, just the walls. Okay, so the shape of the room is shaped as a rectangle. And if you notice in your house, most of your rooms in your house, except maybe your bathrooms or even possibly your kitchen, but most of the rooms in your house are set up like a rectangle, and a rectangle has 2 walls that are the same on each side. So 2 walls are the same dimensions, and then the opposite 2 walls are also the same dimensions, unlike a square where all 4 walls have the same dimensions. So keep that in mind. The shape of the room is shaped as a rectangle, which means 2 sides are the same, the other 2 sides are the same. First, we need to break it up into 4 walls. Okay, for the purposes of this project, we're going to break up the walls into 4 of them. We can call them wall number 1, wall number 2, wall number 3, and wall number 4. We can be creative in terms of which wall is number 1, 2, 3, 4, because it does not designate that in the illustration, so we can be creative that way. What we are going to do is we're going to say, okay, wall number 1 is actually the wall that is facing us, like the most closest to us, and that is the longer side. Okay, so you can see by the dimensions that the length of the wall, which is usually the long, up and down. When you think of length, you think of long. The dimension of that is 8 feet long, so it's 8 feet high. And then when the width and how wide something is 22 feet. And there are 2 walls with that dimension, so we're going to call them wall number 1, wall number 2. Wall number 3 is the one on the left side, and that dimension is 8, because the height you can see is 8, but then also the width is 16. Width is usually how thick something is or how wide it is. So there's also another wall that's directly parallel to that or directly opposite of that, and that's going to be called wall number 4, which also has a dimension of 8 feet by 16. When we do the multiplication for area, our answer is always going to be in square feet. Because what is a square? A square is something times something else. So for instance, 8 times 8 is 64. What is 64? 8 squared. So in this case, with area, we're taking 8 feet and we're timesing it by 16 feet. When we get the answer, that answer is going to be square feet. Moving on to the next slide. Okay, so not only do we have the dimensions of all 4 of the walls, we can go ahead and figure out how much paint Anita will have to purchase with these dimensions. However, in order to save herself some money, we can take into consideration that we do not need to paint the windows. We don't need to paint the doors on the walls. If we did, or if we are going to paint the windows or paint the doors, however, it's not going to be in this particular project. It would be later on. So she can actually save herself some money by subtracting those dimensions. If she included those dimensions, she would actually have to pay, she would actually not be reimbursed for that, and she would have actually had to have paid that. So she wants to get reimbursed for more money, or the landlord does. So then, after determining the dimensions of the walls, we need to determine the dimensions of the ceiling as well. So we've determined the dimensions of wall number 1, 2, 3, and 4, and the dimension of the ceiling, you can see that is actually depicted up top by the amount of area that is, and that's 22 times 16. Okay. Wall number 1 has a door. The door's dimension are 7 times 3. Finding the area means we have to multiply the length and the width. Therefore, 7 times 3 is 21. So that dimension is actually 21 feet out of the entire wall that we do not have to paint, or that the landlord does not have to paint. So, when we take the full dimension of that whole wall, wall number 1, which is 176 feet, and then we subtract the door, which is 21 feet, the only amount of space that we have to paint, or the landlord has to paint, is 155 feet. So that's going to be taken into consideration later on when we add the full dimensions of how much that the Anita has to purchase. So 155 feet is the amount of space that the landlord will have to paint. And that's wall number 1. We're going to move on to wall number 2. Wall number 2 is highlighted in the slide because we've already determined wall number 1. We're focusing our attention on wall number 2, which is highlighted. Wall number 2 has a slider door. Now the slider door is a little bit bigger than the regular door. That is not 21 feet, it's actually 42. It's actually double the size of the door. So this is even more space that does not have to be painted. Okay, so wall number 2, the dimension, we knew that from the previous slide, is 176 total feet. When we take the slider door dimension, which is 7 times 6, and that's 42, when we subtract that from the full amount of feet in the wall, 176 minus 42 is 134. 134 feet is the amount of space that the landlord's going to have to paint, which is great because we've taken all of that amount that we don't have to, and that's going to help us later on in saving money. So we've determined the dimension and the amount of space on the wall that has to be painted for wall number 1, wall number 2. We're going to move on to wall number 3. Wall number 3 is highlighted. That dimension is smaller because as a rectangle you're going to have 2 smaller walls and 2 larger walls. So this wall is 8 times 16. When you take 8 times 16, it comes out to be 128 square feet. 128 square feet, there's a little window on that wall that obviously does not have to be painted, because if you paint a window, you're not going to be able to see through it. So we don't have to paint that. That window is only 4 by 2. If you take 4 times 2, that's 8. We take the total amount of feet on that wall, 128. You subtract 8, that comes out to be 120. 120 feet is the amount of space that the landlord's going to have to paint on that wall. Great. Let's move on to wall number 4. I'm going to take those same dimensions, 8 times 16. We already know it comes out to 128 because we've already done that with wall number 3. Okay, so we have a window on wall number 4, which is a little bit bigger than wall number 3. It's, instead of 4 by 2, it's a 4 by 3 window. It looks to me like it's a little bit more of a landscaped window, but it's a little bit bigger. So 4 times 3 is 12. The total amount of feet in the wall is 128. We do not have to paint, or the landlord does not have to paint the window. So we're going to take 12 feet out of our total, so we don't have to pay for that. That's going to come out to 116. So far, for wall number 1, we have a total of 155 feet that needs to be painted. Wall number 2, we have a total of 134 feet that needs to be painted. Wall number 3, we have a total of 120 square feet that needs to be painted. And wall number 4, we have a total of 116 square feet that needs to be painted. We're going to take this and we're going to put them together. But one of the things that we do need to also consider in the landlord's painting is that he has to paint the ceiling. But obviously there's nothing on the ceiling, there's no walls or doors on the ceiling, so we have to just take the total dimension of the ceiling, which was, the total amount is 877 square feet. So according to the first part of problem, which is number 65, we need to know how much paint, not primer, okay? We're only looking at the paint. So if you look at the paint store price list, there are 2 columns. One is a coat, which is just a regular coat of paint, but then the second column is the primer. So if you've ever painted, you always put the primer down first. That helps the wall, and it holds the paint over the primer a little bit better, and it looks for a better outcome in terms of paint. It just looks a lot nicer when you do a primer first and then paint. You can do a paint without the primer, but a lot of times primer is better. So what we're going to do is we're going to find out how much paint that we need, and we can then look at the chart and determine the prices. So we're going to add all of the feet below. All of the feet below will be added. I'm not going to add that for you because that's something that I'm going to ask you to do. After you've added the feet, you want to look at the coverage column and see how much paint that you're going to need. So look at the coverage column, the price just yet. We want to look at the coverage first, then we can determine the price. So if you need how many gallons from the total, and then you'll need to know how many quarts, that's something that you'll have to take into consideration. And then from there, then you can figure out the price. So if you need 1 gallon, it's going to be $18 per gallon. If you need 2 quarts, it's $5 per quart, so that would be 10. Okay, just as an example. The second part of the problem, 66, is asking you to find how much primer the landlord is going to need on the walls and the ceiling. So you take that total that you've already done, you've already added up all of the total, and then review the chart on the next slide, the same one as the previous slide, to see how many gallons and quarts you're going to need for the primer. So number 66 says, refer to 65. If the landlord will put 1 coat of primer on the walls and ceiling of the family room, describe the quantity of primer that Anita must purchase. Okay. So as an example, now this is not your total amount. It's just an amount that I kind of pulled out of a hat, but it's $375, and the landlord's going to need, if it's $375, we're going to look at the coverage only. We're not going to focus on the price, just the coverage of the primer. We would need 1 gallon, because 1 gallon is 300 square feet, and 1 quart, because 1 quart is 75. When we add them together, we get 375, and that happens to be your total amount. So basically, the landlord would need 1 gallon of paint and 1 quart. So we would look at the gallon of paint, we would say, how much is 1 gallon? $12. We would look at 1 quart, and we would say, okay, you need $3 per quart. If you add them together, that gives you $15. So $15 is the amount. But you need to do that with your amount that you add. So when you finish and you want to do your work on either Word or Paint or any other form of a computerized application or a notepad or phone application, you can then save it and just send it through submissions. This way you don't have to write it on a piece of paper, find a scanner or find a printer or whatever, and then have to upload it and send it. So the best way possible is to just find the easiest way that you can do this work without all the extra steps. So good luck. If you have any other questions, please do not hesitate to email me. My email address is mlong@pit.edu, which you should definitely know by now. Or you can call me in the office if you need any other further questions. Or, of course, if you're a commuter student, please do not hesitate to reach out to me for tutoring. And if you're not a non-commuter student, I also have the application Skype. So good luck, and again, let me know if you have any questions or concerns.
Presentations are a powerful
I'll be more than happy to
communication medium.